Welcome to the Soilcraft Regen Agronomy Podcast. At Soilcraft, our mission is to innovate and lead in the field of regenerative agronomy, forging a path that empowers farmers to produce food that nourishes and heals both the planet and its inhabitants.
Let's see. The question has to do with overwatering, and that is there are ways to to compensate for salt. So obviously rainwater is very good and is very beneficial. But part of the reason why I talk about overwatering is because we're trying to get water not only to cool the outside of the plant if it's overhead, but we also have the capabilities of getting a massive amount of water into the plant, which gets calcium into the plant too. And when you get calcium into the plant, everything starts to, because calcium is such an important part of all plants, and calcium will not get in there unless you have a lot of water. When you're doing drip irrigation, there's usually not enough water going through the xylem in order to pick up enough calcium in order to spread through the entire plant practically instantaneously. And so when we get a lot of water, we essentially are moving calcium in the soil up very, very quickly. And that's kind of what I'm referring to when I'm talking about the overwatering aspect of it. So we can overcome bad water. There are additions that we can do to do that. But when we put down a lot of water, and when I'm talking about a lot of water, I'm also saying, because I know someone's probably thinking this, are you saying we should be watering once a week with heavy water or 3 times a week with low water? And I'm telling you that there's actually a greater benefit to dousing it once a week than it is to just throw a little bit of water at it. Why? Because this is the way nature works.
Right.
It's the way it's always worked.
Great.
Things don't rain every 2 days. That's not the way things work. You get a big rainstorm. I mean, you're from Africa. I mean, come on, Denver. You know about the monsoon season, do you? And so that is a very effective way.
What about if you go back to Genesis, where the mist came up from the ground every day?
Oh boy, if we could only.
So the reason I think that's interesting is, for example, going back to the hop scenario where mites are very prevalent, huge issue.
And drip, yeah.
They're all treated for the most part with drip daily, unless they get oversaturated and they have to back off for a day or two or whatever it is. And my observation a lot of times is it's like a muck. It's oversaturated anaerobic conditions where the drips were constantly running and there's algae and, obviously there's fertilizer being pumped through the drip, et cetera, et cetera. So that's why I thought what you said was interesting, because I feel like a lot of times we have overwatering and tends to lead to more potential stress and or other issues, specifically in the scenario of hops, and that's where we also have spider mites.
But that's where we get into but water. Is it the water? And that's why we see, with our advanced oxidation process that we've been playing around with treating irrigation water, and what you begin to see is the soil tends to flocculate more and you get higher water infiltration rates. Farmers keep kind of telling me, we go out with these infiltrometers and we see an increase in water infiltration from 18 to 28% on average so far as we're measuring this and saying okay, big deal. Who cares? It's going in faster. Why does that matter? And we also at the same time see compaction reducing. But you're not able to do what you're describing unless you can get water to flow down and get a saturation and get it through the entire column, to the soil column, through the first meter or second meter. And so if you can drive that water down, the problem is, I think what happens a lot of the time is that water's just sitting on the surface. It's just sitting, it's not going down. So you're restricted. You can't get the water to penetrate and go down through the entire soil profile. Yeah. And so you end up with these anaerobic conditions on top. We saw it in that potato field that we have treated versus untreated. And that's the first thing we notice is, the treated side's kind of dry and the untreated is wet and slimy on top. And so overwatering, yeah, it can help, but we have to get water that'll move down through it. But there again, we're talking about the difference between rainwater and irrigation water, and why water is not just water.
And that also comes back to the mineral content and balance in the soil. If you have an excess of magnesium or not enough, active carbon, then your water is also not going to flow properly.
Well, why did you say that? You said, when we apply a high rate of water, we see calcium being taken up by the plant with a high rate of water, and it takes a high amount of water. What are you talking about when you describe that? Are you talking about the polar molecule H2O and the electrical charge on it creating opportunity for calcium to come off of the colloid. What about that are you describing, if you don't mind?
Sure, sure. Xylem tissue is where most of the water comes up through the roots. And part of the reason why xylem tissue is less restrictive than the phloem. The phloem is much more restrictive. The xylem is less restrictive. Meaning if you have a significant amount of water in the roots, like right after a rainstorm, for example, and especially if the water's, the ground is dry, the water will come down and the roots will pick it up very, very quickly. They will take it into the plant. It will be sent to the xylem tissue, and through transpiration, it will quickly make its way up the plant. As it's quickly making its way up to the plant, it is lifting heavy atoms. These heavy atoms include calcium. Now, of course, they also include iron, they include copper, they include manganese, and some of these others. This is how these nutrients make it up to the plant. So under drip irrigation, where we find calcium deficiencies, if we can avoid that, the drip irrigation, and we can simply flood every once in a while, we can get all of the heavy atoms up there. Calcium being the predominant one, because calcium is just quite simply more important than really anything else that we're talking about here. So the manganese is important, very, very important. So is the copper, so is the iron. But calcium runs the show. And so because of that, when you have this system, it brings everything up into the plant, it healths it up immediately, and therefore everything is just peachy. The two-spotted spider mite is not attracted to it as much. And if the Brix levels get high enough, no insect is even going to be attracted to it at that point, because the plant will start kicking in, especially if it's getting adequate amounts of manganese. Calcium is, of course, used in chloroplast. The manganese is breaking water. And so when all this system is working, photosynthesis is occurring. The plant has got sugar, it's got energy, it's able to rock and roll, it's able to party, it's able to do what it's supposed to do under these situations that we're outlining right now.
Now you mentioned, a mechanical aspect of the xylem.
Yes.
As it's lifting, if you will, those heavier elements, again, back to kind of Pollock's work on gel states or protonation, almost a pulling, right? A pulling impact and effect, but that requires those living waters. It's not just water, but I wonder, is there something that you can speak to about that, about, again, the quality of water, because we're playing around with some of these different waters, or treating our water to try and create protonated water, basically water which has charge, right? Could that be a way of describing that? Would you agree with that?
Not necessarily. I mean, there are charges that are associated with rainwater. Let's just consider that to be the standard.
Okay.
There are charges associated with it because, of course, it usually is accompanied with a thunderstorm, usually. Right. And so therefore you have high ionic activity in the atmosphere. And so, yes, that would be charged water. So yes, that is certainly going to be a factor. Irrigated water, a lot of it is dead, but not all of it. And so there are ways in order to charge the water up. There are lots of products that are out there that will do that for farmers. And so, yes, I can speak to that effect and simply verify what you are saying, is that it is more than just H2O. It's not just about getting water in there. Having the various charges, having oxygen associated with that water, opening up the soil, everything becomes more efficient. Everything is working better. The more oxygen you put into the soil, the more the aerobic microbes are working too. I mean, essentially, it's just a whole system that is working much more efficiently than it was before.
Right. Okay. And that's going to facilitate, the transport of those essential nutrients, those more essential nutrients, and going to lead to sugars, complete sugars, etc. Yeah, Trent, you've got something.
I feel like this leads me. I need to at least say what I'm experienced, and then hear what you have to say, Tom, about this, because I feel like that the comment about oversaturation, or not necessarily oversaturation, but an increase in overwatering could potentially increase or help calcium uptake into the plant. And in my observation, I think that might be a little too generalized, because it depends upon the availability of the calcium in your soil and everything else that's in your soil, such as potassium, phosphorus, these other things that are interacting with the calcium.
It does.
We have directly noted that specifically, for example, and I'll give one example, apples, and specifically Honeycrisp apples, seem to hyperaccumulate potassium very easily. And so farmers found during a drought several years ago where they had less water, especially early on in the growing season during cell division, they found they had much higher quality apples. And so I took that and we experimented a little bit, not scientifically, but just observationally, that when we have less water earlier in the season during cell division, and then we seem to accumulate more calcium and less potassium, because calcium being less water soluble, potassium being highly water soluble, it seems like, at least within the soil structure, that in low areas where we get more water, we hold more moisture, we tend to have much higher levels of bitter pit in those apples. And we know that bitter pit in those apples is a hyperaccumulation or more potassium within the cell wall structure than calcium. The university has done some, Bruker XRF scanning on apples that have bitter pit, apples that don't, and the sides that have bitter pit have much, much higher levels of potassium than calcium. And so we've observed that managing water, especially during cell division, is extremely important with, I guess, not allowing too much water soluble, for example, the ratio between calcium and potassium to be absorbed up into that plant. And maybe it's not just potassium, it could be nitrogen causing excess growth, which then uses more calcium and keeps it from going into the fruit and pulling into the leaf, or et cetera. But I'm just wondering what you think about that.
You said a key word there, enough. It has enough water. So what I was suggesting, and this is a hypothetical situation, certainly more common as you might find in Africa, is that when you have a lot of water coming down, you allow things to dry out, and then water comes down again. So when I was talking about, let's say, watering once a week, rather heavy, the plant is getting enough water. You can also drip it in and give it enough water. But if you give too much water, if you have monsoon conditions, too much water, or if you have too much drip irrigation, we have algae growth, you were talking among other things, that would simply just mean too much. So that's the key word here, enough, a critical amount. The tree can regulate it as long as it gets enough. And so there are situations, and we're seeing it, yes, in bitter pit right now, that water is a big factor. That is what I was trying to say. Water is a big factor. It is a factor in calcium, and therefore it is going to be making a difference. And we're both saying the same thing, but the key is that we want to make sure that we both have enough. So whether we go with two different systems, let's just say a drip irrigation system, or whether we go with a once a week system, that I'm just suggesting right now, as long as we had enough, we're going to have a healthy apple. However, both of us could overdo it. And so those are some of my thoughts on what you just mentioned right now. But you can get lost in the details, as I'm sure we could.
It's a good point, though, and I wonder. So as we're really contrasting drip irrigation as opposed to more of a flood style overhead irrigation or something, but it's not just one size drip. You can get different rates of drip tape, for instance. So
yes,
could a potentially better way to find to bridge this gap, because a lot of times growers that I'm working with often use drip irrigation because they're limited on their total volume of water in relation to their arable acres. So they're saying, well, on trees, especially whether it's macadamias or avocados, et cetera, et cetera. So could it be perceivable that you could go with a higher rate drip irrigation so that you're applying more water in a shorter period of time with drip tape,
of
and
course,
leave longer periods of rest between? And that could potentially have a similar impact.
Of course. Yeah, of
because
course.
you'll just have, you'll be watering fewer blocks at a time. But since you're giving a long rest, you can just go through them, because that's something that drives me crazy with drip irrigation. Is it's a very unnatural means for irrigating. And that's to your point as well, though. And yes, you're right. There are ecosystems that, like the tropics or back to the Garden of Eden, that had this mist. And bananas are one. Like, we grow bananas in Zambia, and they love relative humidity, and so we like to keep our rows just tight enough that it creates a microclimate, so that there's more, that they'll actually draw a lot of moisture from the environment, the atmosphere, into their leaves. But certain plants are more adapted to those type of environments. And so bananas, for instance, they'd like to keep it on the wetter side. You still have to they have breather roots, so you have to have that, but they prefer more of that environment. But you take a macadamia tree like we have, and I think that's some of the problems macadamia is on drip. You go to these natural environments, and I think you'll see that they have more of these monsoon patterns where you'll have these big rainfall events and then a period of time in between where the soil can drain and you can restore that air, that oxygen balance. But
And then the roots grow. The roots are usually growing when things are dry. You don't get
Right.
too much root growth if the soil is wet all the time.
wait, that's huge. That
That
statement you
is
just made
huge.
couldn't be. Can you repeat that? I think it needs repeating.
Yes.
Sure. Roots do not grow in a high watery environment. They only start to grow when things dry out. So when things dry out, the plant will start taking energy and will throw it into the roots, and they will start extending the roots looking for water, which makes sense. And so you don't get that. And so if you're constantly putting water down and you have too much water down, you have very tiny roots, especially in the drip irrigation system. The roots are usually in a ball right where the drip irrigation is dripping out of, because they're not going to spread because there's no water spreading out. They're just going to collect around that that particular, pore that may be in the drip irrigation system. So
That is huge. That is so huge, because what happens when you don't have active root growth? You don't have a lot of hair roots. Those hair roots are responsible for calcium on a lot of things we need uptake,
Yep.
not the big large ones, but all the little tiny ones. And then in all of the active growing root tips is where you get cytokinin production. And so you need cytokine production for more bud sites, more leaf, more lateral branching, et cetera, for the plant above ground. And if you don't have that, that's when you get this more elongated, apical dominance, not the reproductive plants that we want if we don't have active root growth.
And we
That
also
is
know the
huge.
other organisms that pair with plant roots to extend the root systems are hyphae, fungal hyphae, mycorrhizal fungi, etc.
they need lots of water.
They don't grow. They won't grow if it's waterlogged. They need to have a period of time, and it's a perfect period, right? We want that perfect, but it is. Things go. It's just like you're saying. Okay, you get a restoration, and so you need a saturation of water, but then you need a period where things can dry out, and then things can reach out, and then water can come. It's just amazing.
That's the healthy cycle. That's the healthy cycle by design.
Right, exactly. By design.
So,
That's what happens
so
to it.
with all of this, you were describing methods.
Oh, no, I'm going to stop you right there. I do need to go.
Okay.
So
No problem. That's perfect. Hard stop. So, okay. So thanks, Tom, for joining us. Really appreciate taking time out of your schedule and day, and I look forward to, hopefully, as your schedule will allow and ours will allow, we can meet and discuss some more topics, because, man, the things we're cracking into here are incredibly deep, but profound as well. So thanks.
And
for
unplanned too. I like the unplanned nature of it. That's pretty cool.
Oh, you do like that?
Oh yeah, because you don't know where it's going to go. I had no idea where we're going to go during this conversation. So
We totally knew exactly where we were going. The whole
you guys are professionals. That's why.
No, thank you for saying that, actually, because that's, and I hope you, the viewers, really appreciate this. Like, we're really out to have good conversations and to unearth things. And we do have, look, we have agendas, we have things we're working on, but really we want, like we said before we started the podcast, we want to know what excites you. We want to know what's going on with you. And so I'm glad, thank you for being flexible and working with that. And if it works for you, please, we'd love to do it again and just continue learning. Because I feel like the information you have, the space you're in is very, very hard to find. There's just not information like it elsewhere. And we see it. I think we see it when you talk about these things. We're like, that's what we're seeing. We're seeing these
Very
things.
valuable.
So thank you for your
Thank
work
you.
and your research and your willingness to share it. And I look forward to doing it again. Thanks so much for joining us as we expand our paradigms and explore what's possible in the realm of regen agronomy. If you would like to contact us or learn more about what we do, please visit our website at www.soilcraft.com, as well as our YouTube channel. If you have topics you would like us to unpack or stories, please connect with us so that we can share them with others.